Okay, so this problem says a wooden artifact from an ancient tomb contains 55% of the carbon-14 that is present in living trees. How long ago to the nearest year was the artifact made? The half-life of carbon-14 is 5,730 years. So, first off, this is a half-life problem. And this is carbon dating. This problem is describing for us how scientists do carbon dating, how they can figure out how long ago something died. Because living objects, animals, people, and plants and trees, when they die, their carbon-14 begins to break down that's in their body, the minute of death. So when you're alive, when a tree is alive, or a plant, or an animal, when it's alive, the carbon-14 is held in a steady state. But the minute that a living thing dies, the carbon-14 inside of it begins to break down. And it breaks down very slowly. It takes 5,730 years for half of the carbon-14 to dissipate into the atmosphere, to just kind of go away from the body, or from the tree, or from the whatever thing just died into the atmosphere. So it's a time clock. The minute the thing dies, the carbon-14 begins to break down. So if they find something that's been dead for a long time, scientists can see how much of its carbon-14 it has left. And from that, they can calculate how long ago it died, because they know it loses half of its carbon-14 every 5,730 years. That's how long that's the half-life of carbon-14. So let's do that for this wood artifact on this problem. They found a wood artifact from an ancient tomb, and it has 55% of its carbon-14 left, the 55% that is normally in a living tree. So how long ago was the artifact made? Did the tree die, in other words? Well, let's move it to a fresh screen. We've got some room to work on this one. And I'll write down the details for us here. So the carbon-14 on this one, it's let's start with the half-life. The half-life of the carbon-14 is 5,730 years. The wooden artifact didn't do that well. The wooden artifact has 55% of the carbon-14 of a living tree. So in other words, the normal amount that a living tree has, it has 55% of that, so it's lost a bunch. All right, so what formula are we going to use? Well, this is exponential, right? It's half-life. So, and their question, how long ago did the tree die? They said, how old is the artifact? Basically the same thing. How long ago did the tree die? So we can use the exponential equation, y equals a times b to the t, because there's a half-life. Whenever you're multiplying by the same number every time, in this case 0.5, half, that's always exponential, meaning t is up in the exponent zone. So a is always the starting amount. B, you know what we do the 0.5, that's because of the half-life, that's half, right, to the t over the half-life. That's always how it works. So that's the formula we use. 0.5 to the t over. Now what is the half-life? 5730 years. So there we go. The half-life is 5730 years. Now the wooden artifact has 55% of the carbon-14 of a living tree. So that means what? Well, we can take this and plug it in right here, right? 0.50, make it a decimal, of course, 0.55. That's the amount of carbon-14 left but hold on, there's one mistake. That's actually wrong. There's something I'm doing wrong there. I do it that way on purpose because this is what students do a lot I've seen over the years. It's a common, easy mistake to make. What's wrong with it? Isn't that right? That 55% is left, plug in 55%. That's the amount. Well, let me help by asking this. What if I just said to you out of the blue, hey, 55%? 55%. And I just stopped. Wouldn't you think 55% of what? There's no such thing as a percentage or a decimal alone. It's a percentage of something, a part, a decimal, a portion of something. Right. So it's 55% of what? It's 55% of the carbon-14 of a living tree, meaning the starting amount, the amount of carbon-14 that a living tree has, the amount it had at the start when it first died and then began to decay. So it's 0.55 or 55% of the starting amount. And what's the starting amount? That's always A, isn't it? The starting amount is A. So it's 0.55 of, and what is of always? Times. Of is always times in math. A, the starting amount is A. So it's 0.55A. That's what should go there. I'm missing the A. It's not just 55% alone. It's 55% of the starting amount, of the amount that a living tree has, which is the amount it had at the start, right when it died and then began to decay. Okay, so that's correct now. Now we have to take that equation and solve for t, because they said how long ago, when did it happen? So we have to solve this equation for t. So how do we solve that equation for t? Well, the first thing we're going to do is we're going to divide off the a on both sides. It's a good thing we had the a on both sides, that way we can just get rid of it. To the t over 5730, like that. Okay, now I'm going to bring this up here. So I'm trying to solve and rewrite it here. 0.55 is 0.5 to the t over 5730. Now, what do we do? How do we solve for t? Let me bring it down here. Solve for t in power. Notice the t is up there in the power zone. What do? Remember, how do we deal with powers? How do we deal with something that's in the power zone? What do we do when the t is in power? What's the opposite of a power? We L in both sides. Remember that? Powers and logs are opposites of each other. So when you have your letter in power, you L in both sides. Natural log both sides, and then step 2, what happens? The power drops down to the front. So you grab that power and you drop it down to the front. So you get L in of 0.55 is t over 5730 times L in of 0.5. Right, that power drops down. Now we just got now that we got t out of power, we just got to finish getting him alone. So let's divide both sides by L in 0.5. Boom, boom. I'm going to get this out of the way. Got a little more work to do here. Keep this all separate. Okay, so we've got now L in 0.55 over L in 0.5. These are gone. So in fact, actually, let me scoot things to the right just a little bit. ln 0.55 over ln 0.5 equals t over 5730. So last step to get the t alone is we're going to multiply by 5730 over 1 multiplied by 5730 over 1, because that cross cancels. T is alone. Take your calculator, multiply that out. You'll get 4942 rounded to the nearest whole number of years. That's how many years old. So I just took I'm running out of room here. That's the problem. On this problem, let me go back like this. That'd be better. And put this back how it was here. So I multiplied both sides by 5730 over 1. So take your calculator, do that. You get 4942 years. That means that artifact, that wood tree, died 4,942 years ago. That's how long ago it died. That makes sense because it's got more than half of its carbon-14 still left. So it's not halfway down. It hasn't reached its half point, and that would take 5,730 years for half of it to go away. So it's got to be an answer less than 5,730. That makes good sense.